So in this video, we're going to be talking about sums and products of matrices. I'll start with sums because they're a lot simpler and more intuitive to understand. So if I take two matrices, let's say 1, 2, 1, negative 1, and 3, 7, 1, negative 4, the sum of those matrices is going to be pretty much exactly what we expect. It's going to be 1 plus 3, 4, 2 plus 7, 9, 1 plus 1, 2, minus 1 plus minus 4 is minus 5. Alright, so sums work exactly like you would expect sums to work. If I take 1, 2, 1, 1, 2, 3, plus 1, 2, 2, 1, then this is not defined. Right? And so you can only sum two matrices together if they have the same dimensions. Now, products are a much different kind of thing. And so let me describe what the products of two matrices look like. So you have two matrices, and this first matrix has m rows and n columns. The product is only defined if the second matrix has n rows and k columns. Right? So what that means is that the number of columns here has to be the same as the number of rows here. And the resulting matrix is going to have m rows and k columns, where you get in the ith row and jth column, that entry is determined by taking the ith row here, taking the jth column here, and multiplying each of the entries here together and adding them up. So this is fairly ugly, I get that. So let's go ahead and knock up kind of a quick example to sort of illustrate what's going on here. So let's say I have 1, 0, 1, 2, negative 1, 0. So let's say I have a 2 by 3 matrix, and let's do something that's 3 by 4. So this is 2 by 3, and this is 3 by 4. So 1, 3, 2, 1, negative 1, 0, 0, 2, 0, 2, 0, negative 3. And I'm just putting some zeros here to make my life easier. So the resulting matrix here is going to have is going to be, let me switch colors maybe, 2 by 4. I'm going to get the first entry of that matrix by taking 1 times 1. So that's 1 plus 0 times negative 1. So 1 times 1, 0 times negative 1, and then 1 times 0. So the entry to my first matrix here is going to be 1 plus 0 plus 0. Then underneath it, I'm going to need more space than this. I have 2 times 1, so 2, negative 1 times negative 1, which is 1, 0 times 0, which is 0, and that gives me my first column. And then I do the same thing with the second column here. So 1 times 3 is 3, 0 times 0 is 0, 1 times 2 is 2, again 1 to 3, 0 to 0, 1 to 2, and then 2 to 3, which gives you 6, negative 1 to 0, which gives you 0, and then 0 to 2, which gives you 0 again. And then we would do the same thing for the last two columns, and that would be our 2 by 8 matrix, which would be 2, 3, 5, 6, and then whatever these entries were. Now, there's a whole class on matrices and their properties and why we define sums and products in this way that I'm coincidentally teaching at the same time this semester. And we can get, in that class, we get into a lot of detail as to why we define the product this way. Because this is not the obvious way to define the product, and it would seem like it would make more sense to define it the same way to define multiplication, right? To just make it entry by entry. So, yeah, the question arises, why do we define products this way? So let me illustrate by giving an example here. Let's say you have C cats and D dogs, and for every cat, in order to feed all of these cats and dogs, let's say all of the cats need 3 cups of water and 5 cups of just general pet food. And each dog needs 5 cups of water and 6 cups of the general pet food. Alright? And so what are we doing? What we're trying to do here is answer the question, alright, given some number of cats and some number of dogs, how much water will I need and how much of the general pet food will I need? So what we're kind of defining here is a setup where you have one matrix, which is just a 2 by 1 matrix, where you have C cats and D dogs. And you have another matrix which corresponds to the amount of water. So let me annotate this. So this is feed type. And this over here is animal type. So maybe in the first column here, we would have what cats need. So cats need 3 cups of water and 5 cups of pet food. And what the dogs need are 5 cups of water and 6 cups of pet food, right? So now if I take this product, what I end up with is, I'm going to need wider than that. What I'm going to end up with is 3C plus 5D, right? 3C, 5D for my first entry. And then my second entry, it's this row against that column, 5C plus 6D. In other words, this matrix represents a sort of transformation from animals to feed. Right? Every time I multiply by a matrix, it's meant to transform one type of variable into another type of variable. So hypothetically then, if I had 1 cat and 2 dogs, that would turn into 13 cups of water and 17 cups of the pet feed. Now, let's say each type of feed took different types of ingredients to make. Then, and we want to know how many of those ingredients we needed. That would be a different matrix. That would correspond to that transformation. But the point is that we multiply it this way because both cats and dogs contribute to the amount of water needed. Both cats and dogs contribute to the amount of pet food needed. So our product structure here should capture that, right? It should have a component that's part cat and part dog, part cat and part dog. All right. So having said all of this, once again, we can see that the process of adding and multiplying matrices is somewhat arduous to do by hand. And so let's go ahead and take a look at our example here, right, where we had to take the product of these two matrices, and you can see on, once again in the text, that we have a cell corresponding to matrix arithmetic. So let's go ahead and enter in our first matrix. Let's let A be the 2 by 3 matrix. So 1, 0, 1, 2, negative 1, 0. And let's let B be our second matrix, which was 3 by 4. So it's 1, 3, 2, 1, negative 1, 0, 0, 2. And that's putting one more row for the third row. It's 0, 2, 0, negative 3. And what I'm looking for is A times B. And what we have is 1, 5, 2, negative 2, 3, 6, 4, 0. And we could see, we started to see that, right? Oops, yeah, this should have been a 1, huh? Right, 1 plus 0 is 1, clearly. So 1, 5, blah, blah, 3, 6, blah, blah. And we could also do this in decimals as well. So if we let A be 1, 0, extra column 1, 2, -1, 0, and we let B be, so it's 3 rows, 4 columns, 1, 3, 2, 1, -1, 0, 0, 2, 0, 2, 0, -3, then we get that AB is that same system of equations, or that same matrix, sorry. And we note, by the way, that in this case BA is not defined, right? Because if we look back here, if I try to swap A and B, right, then we would be taking a 3 by 4 matrix against a 2 by 3 matrix, and these dimensions don't coincide. So that product is not defined. The bottom line is that matrix multiplication differs from, say, regular multiplication in a number of fairly significant ways. And I think the biggest one is that AB and BA don't necessarily have to be the same. Or one could be defined and the other one might not be, right? But if you look at the product structure and how complicated that is, that makes sense, right? So, thank you very much for watching. Hopefully that was instructive. If you have any questions, please let me know, and I will see you in the next video.